Each 46 chromosome spermatogonia divides through mitosis to produce primary spermatocytes. These cells divide by meiosis to become 23 chromosome cells called secondary spermatocytes, then spermatids. This multi-step process, called spermatogenesis, produces the 23 chromosome immature sperm cells that mature in the epididymis.
Okay, let's review some important topics regarding male reproductive system. What do you remember for male reproductive system? You should remember spermatogenesis. It's the process that sperm produced by spermatogonia's divisions, yes, and capacitation. We have 3 steps for capacitation. Inhibitory proteins washing away, the membrane of the sperm become weaker, and calcium enter into the membrane. What is the next step after capacitation? Acrosomal reaction, yes, excellent. Acrosomal reactions happen to penetrate the ovum and send nucleus of the sperm into the ovum's site. So, what do you remember from androgens? Come on, we discussed 1 hour ago. What do you remember from androgens, my dear sir?
In males, a group of sperm.
Yes.
Testosterone.
Testosterone increase during pregnancy for differentiation of genitalia into male, and after birth, testosterone increase in the first month after birth, and then release to the zero until puberty. After puberty, testosterone level increased until age around 50 years old. And after 50 years old, the level of testosterone gradually decreases by any years. And testosterone, how testosterone circulates in the blood, my dear friends? How testosterone circulates in the blood?
By binding to protein, or 0.3 to 0.5 is free. And
Yes.
SUVG.
Yes, excellent. Testosterone binds to the testosterone binds to some kind of globulin, sex-specific globulin, and circulate in the blood. All steroidal hormones, my dear friend, should bind to a protein and circulate in the blood. The steroids, hormones, always should bind to a protein.
SUVG. SUVG.
Yes. So, any question? No. Let's start last session. At the end of this session, you have a quiz. Okay, so please pay attention to important topics that we emphasize, or I'm telling you that this is important, and please pay attention at least to important topics that we are discussing in this session. Sorry. Sex-specific globulin.
Yes, what's the function?
They bind to testosterone and helping for circulating testosterone in the blood.
In addition, by the SHBG.
SUV.
No, SH. It's hormone that is tightly attached to the testosterone and the
Yes, yes.
So it is the extra protein. In
Yes,
addition
yes,
to that,
yes, yes. So, my dear friend, again, let's see the brief anatomy of female circulatory system and see the function of ovary. In the female, we have 2 different parts. One part is ovaries. We have a circle and cycle in the ovary, and we have another circle that happened in parallel with ovary in the endometrium. endometrium. So we have two parts, endometrium and ovary. We have different circles, but they are in parallel with each other. So, about anatomy, my dear friend, the internal genitalia of female contain ovaries, fallopian tubules, uterus, and vagina. External genitalia connected to the vagina, and we have external vagina and external genitalia of female. In the internal genitalia, my dear friend, ovaries are inside the abdomen, and fallopian tubules connected to the uterus, and uterus connected to the vagina. You know better than me the anatomy of these parts. So let's see the HCG axis in the female reproductive system. As I told you, the GnRH stimulate gonadotropin secretion, FSH and LH. FSH defined as follicle stimulating hormone, FSH, follicle stimulating hormone. Its name coming from its function in the female's ovary, stimulate follicle growth or stimulate follicle development. Okay, follicle stimulating hormone. Please remember it by its definition, and you can, if you remember by its definition, you can find its function. Follicle stimulating hormone, FSH. LH is coming from luteinizing hormone. Luteinizing hormone. Luteinizing hormone. Lutein, it means yellowish, yellow, or yellow color. Luteinizing hormone, it means a hormone that related to going to yellowish the ovary. What is the yellow mean? Yellow is coming from the absorption of cholesterol. I mentioned that all steroidal hormones origin is cholesterol molecule. So in this hormone, this hormone's name is coming from when the ovary absorbs high amounts of fatty acids and cholesterol to produce estrogen and progesterone. They absorb cholesterol and then produce estrogen and progesterone from these cholesterol. So FSH and LH. Follicles both ovaries has. As you are seeing here, my dear friend, before birth, during pregnancy, number of follicles increased to even 7 million follicles. Follicles, it means oocyte, germ cells in the ovary. Follicles is the oocyte with one layer of granulosas. I will show you the picture of them. Okay. So, during pregnancy, number of follicles in the ovary reach to the 7 million, as you are seeing here, but gradually decrease and decrease and decrease until at the onset of birth, the number of follicles reach to 2 million number. But after birth, again decrease and decrease and decrease and decrease until at the onset of puberty, the number of the reservation of follicles and number of follicles in the ovary reach to 300,000. Do you think all of them has a chance to release from the ovary? No. Only 400 to 500 number of them during life, reproductive life of female has a chance to expel or release. Expel from the ovary, it means release from the ovary. Expel or release. Expel or release from the ovary. So as you are seeing, in the female reproductive system, there is a limited amount of ovaries that has a chance to expel. Female reproductive life is very short between puberty until the menopause. There are differences between male and female reproductive system.
So doctor, you mean the female when the uterus of her mother, it can produce the oocyte?
Yes.
Yes.
So, my dear friend, the follicle that I mentioned is this: the oocyte, the germ cell, the yellow cell, with one layer of granulosa cells. Granulosa cells is somehow like Sertoli cells. Do you remember Sertoli cells? Sertoli cells protect spermatogonia and germ cells in male reproductive system. Here, you can remember this granulosa cell that is around oocyte and produce follicle is like Sertoli cells in the male reproductive system. Granulosa cells can be like can be considered as Sertoli cells in male reproductive system. Okay, so granulosa cells, as you are seeing, is one layer, and with oocyte with one layer of granulosa cells named primordial follicle. You will be familiar with these names in the histology of this blood. Okay, but here we want to discuss about the effect of hormones in this process. So, this follicle, this primordial follicle, stay in the ovary until the puberty. By the effect of estrogen, this follicle start to grow and development. What is the growing and development process you are seeing here? Growing, it means that number of granulosa cells increase. As you are seeing, there is a multiple layers of granulosa cells are around the follicle. The development of follicle, it means that the number of granulosa cells increase in around the follicle. And you are seeing again size of follicle increase and increase until we reach to the antral follicle level, antrum. Antrum is the space between granulosa cells. My dear friend, granulosa cells produce which hormone, if we assume that it's equal to Sertoli cells? Estrogen. Granulosa cells produce estrogen, and this secreted estrogen are trapped in this antrum. This secreted estrogen are in here. This space are full of fluid, and this fluid contain estrogen hormone. Okay, granulosa cells grow and grow, produce estrogen and release estrogen. Finally, estrogen trapped in some spaces, as you are seeing, antrum. And when the follicle reaches to this level, we said it's an antral follicle, a follicle with an antrum. Please pay attention. You have an exam. A quiz at the end of this session. So, this antral follicle again grow and grow and grow until become ovulatory follicle. Ovulatory follicle finally ovulate from the ovary. Ovulated follicle finally expel or release from the ovary. So this process means named as development of follicle until ovulation. Okay? Repeat. I'm talking about follicles in the ovaries. We have one oocyte with one layer of granulosa cells around it. When there is estrogen signaling into the ovaries. After puberty, the amount of estrogen increase, and this estrogen starts follicle to grow. When I'm talking about growing follicle, it means growing the granulosa cells. Granulosa cells increase, number of granulosa cells around follicle increase and increase and increase. There is multiple layers of granulosa cells until granulosa cells secrete estrogen, and this estrogen trapped between granulosa cells, and we have some spaces between granulosa cells that is filled by estrogen hormone. Yes, there is a fluid in here that is full of estrogen hormone. And this estrogen, this follicle again grow and grow and grow, become ovulatory follicle, and finally ovulate from the ovary. Do you know the meaning of ovulation? Yes? Okay. This process named development of follicle. Which gonadotropin has the most effect on this process? Which gonadotropin? FSH, excellent. FSH, follicle stimulating hormone, based on its name, is important for development of follicle growth.
And also the LH, because if we don't have the LH, the ovulation doesn't happen.
Yes, LH is mostly important during ovulation, at the end of the growth period. Yes? Okay. Here is another histology. This is the outside one layer of granulosa cells. When we are saying that the follicle development is happened, granulosa cells layer increase. As you are seeing, granulosa cells increase, and granulosa cells secrete estrogen between them, estrogen trapped between granulosa cells. We have some spaces named antrum, and finally we have a big space named, again, the antrum with a big antrum, and this follicle must be ovulate from the ovary. Any question? Okay, so my dear friend, what do you think about a number of developed follicle in each cycle? We have a cycle, and in each cycle, only one follicle expels from the ovary. Yes? How is it possible?
Because the maturation between the follicle are different. Because, for example, when we have the concentration of SH, it is low, or maybe the speed or that makes the follicles become grow, because some follicles are growing very fast, but another is so slow. So because of that, we can say just one is ovulation.
Yes, that's right. At the first of cycle that we are talking about, at the first of follicle development cycle, 10 or 12 number of follicles starting to grow. 10 to 12 number of follicles starting to grow. They are growing under the effect of which hormone? FSH. FSH acting on these follicles to grow. So there is a competition between follicles, and one follicle grow faster rather than others, my dear friend. One follicle, for example, this follicle grow faster rather than others, and reach to the antral follicle faster rather than other follicles. Antral follicle, when we are talking about antral follicle, it means that that follicle has its own reservation of estrogen. Yes? It means that they are not dependent into FSH anymore. Other follicles are dependent to FSH for their growth. But this antral follicle, please pay attention to this sentence, this antral follicle, because has their own estrogen reservation, this antral follicle has no need to to FSH. The other follicles dependent into FSH. Other follicles dependent into FSH. So what happened? The estrogen level in this stage, my dear friend, increase. The estrogen increase by growing these follicles, estrogen level increase. And we know the estrogen has a negative feedback on FSH. Yes? Estrogen has a negative feedback on FSH. So FSH was inhibited. FSH was inhibited, and some follicles that depend to FSH for their growth, they degenerate. Let me show you by another picture. Here. Please see, hypothalamus produce GnRH. GnRH act on the pituitary to produce LH and FSH. We know that in this stage, FSH is important for follicle growth. FSH acts on the ovaries to growing follicles. 10 to 12 number of follicles start to grow. These follicles growing by different growing ratio, and one of them is growing faster. One follicle growing faster and reach to the antral follicle. And the antral follicle, it means that the follicle is full of estrogen. This estrogen, my dear friend, again circulate in the blood and inhibit FSH, inhibit GnRH. FSH, by this elevated level of estrogen, FSH was inhibited. So some small follicles that depend into FSH for their growth, they become removed. And only the larger follicle, the one large follicle, remain, and we set this follicle as a dominant follicle. Dominant follicle. Finally, this dominant follicle expelled from the ovary. That's why in each cycle of ovary, only one follicle expelled. Because one of them grow faster and one of them become dominant follicle and reduce FSH level, so other follicles degenerate, and only this dominant follicle remain and finally expelled from the ovary. Yes. We are answering the question that why in each ovarian cycle one ovary expelled from the ovary, okay, released from the ovary. And we are talking about the process during follicle development. At the first, by the effect of FSH hormone, FSH acts on the ovary and stimulate follicle growth. Yes, some follicles starting to grow. One of them grow faster. And reach to the antral follicle faster rather than smaller ones. These follicles dependent to FSH for their growth. But this follicle, because it has own estrogen reservation, this follicle don't need to FSH. Okay? So, what happens when the follicles are growing? The estrogen level in the blood increase. The estrogen level in the blood increase. And this estrogen circulates in the blood and inhibits GnRH and FSH. So, because we know that estrogen has a negative feedback. And this estrogen inhibits GnRH and also inhibits FSH. So what happened? All follicles, all small follicles that depend into FSH will be destroyed and degenerate. Only the larger follicle remain, and this follicle grow and grow and grow until ovulate from the ovary. Okay?
If the follicles are grow, so will be oocyte or not?
Yes, yes. This is oocyte. This is oocyte. And these green parts are granulocyte cells.
Around the granulosa we have the theca. Around the granulosa we have the theca.
Thicker. Yes.
Theca.
Yes.
T-H-E-C-A-R. C-A. Theca.
Thicker. Yes, yes. That's right. Okay. As you are seeing here again, the ovaries produce estrogen. Estrogen has a negative feedback to decrease FSH, and finally the small follicle, because of insufficient FSH, will be degenerate, and only large follicle become dominant follicle and stay until the ovulation. Here, this is oocyte, my dear friend. These green cells are granulocyte cells, and we have another type of cells in here.
Theca.
Theca cells. What do you think about theca cells? Function?
The outer cells.
The outer cells, they are around the granulocyte cells.
It is responsible for secreted some enzymes such as aromatase that is responsible for changing the male hormone to female hormone like testosterone, which changes to the estradiol.
Granulocyte cells has aromatase enzyme. Theca cells has no aromatase enzyme.
An important role in cell splitting. Has an important role in forming the corpus.
Yes, yes. The corpus, after expelling the oocyte from the ovary, this part expel. This part expel, my dear friend. Here, this part expelled from the ovary, and remaining granulocyte and theca cells, as you are seeing, the blue cells are theca cells. Remaining granulocyte cells and theca cells become corpus luteum that produce estrogen and progesterone. Estrogen produced by which type of cells? Granulocyte or theca cells? Granulocyte cells has aromatase enzyme. Granulocyte cells has aromatase enzyme. So estrogen produced by granulocyte cells, yes?
Yeah.
Okay. Theca cells produce progesterone mostly. And also, my dear friend, in the histology, we know about that. Theca cells divided to internal and external theca. Internal theca is involved in producing hormones. External theca is like connective tissue, bind this follicle into the ovary. Here you are seeing a beautiful picture of rat as a rodent animals. Oocyte, these are granulocyte cells. This is antrum or space. This is oocyte, and this is granulocyte cells around oocyte. These are Teca cells. You are seeing the all types of cells in the follicle. Can we continue the class without break until yes. Yes. If you are tired or feel sleepy, try to deep breath. Okay. Refreshing. Sleeping students, breathe deep breath. Okay. So, this part is not for the final exam. Let's talk about the cycle. The cycle that we discussed until now, the stimulation, the follicle growth, is a part of follicular phase. In the ovary, my dear friend, we have a two phase, follicular phase and luteal phase. Both of them, they are taking 14 days. First 14 days is for follicle growth, and second 14 days is for corpus luteum activation. So in follicular phase, that is the first phase, the follicle development is happen, as we mentioned earlier in here. This is a part of follicular phase. Follicle develop until the follicle expel from the ovary. At the end of follicular phase, we have ovulation. Ovulation, it means the dominant follicle expel from the ovary or release from the ovary. And the second 14 days start. After ovulation, we have second 14 days as a name, luteal phase. Luteal phase, it means the phase that corpus luteum is present and corpus luteum producing estrogen and progesterone. Excellent. The phase that the progesterone and estrogen level increase in the female's blood. So, in general, it takes 28 days, first 14 days, and second 14 days. First 14 days named follicular phase, second 14 days named luteal phase. This is the ovarian cycle. Ovulation occurs by the rupturing and damage of ovary wall. So maybe on ovulatory day, the female feels some pain. We said that the middle pain, it's because of the rupturing of the ovaries wall, and maybe bleeding also maybe is happened during these ovulatory days. And in some cases, in 1 or 2%, maybe there is more than one follicle from the ovary. More than one follicle may be expelled from the ovary. It's very rare. Normally, we know that most of the time only one follicle expelled from the ovary in each ovarian cycle. You are seeing the schematic of this cycle in here. From the one, the follicle growth and follicular phase is seen until the stage 7, the ovulation is happened, the follicle released from the ovary, and finally this remaining granulosa and Teca cells become corpus luteum, the yellow body corpus luteum. And corpus luteum, in the case of not pregnancy, degenerate into the corpus albicans during these 14 days. If there is no pregnancy, corpus luteum convert into the corpus albicans and finally remove from the ovary. But if there is a pregnancy, corpus luteum maybe stay until the end or until 2 months of the pregnancy. Until the placenta produce, the corpus luteum still remain and producing estrogen and progesterone. My dear friend, this is another beautiful picture of ovulation. This is ovary. Here you are seeing the oocyte with granular vessels around them. Then this oocyte expel from the ovary and go into the fallopian tube. The fibria of the fallopian tube are guiding this oocyte into the So the luteal phase consists corpus luteum's function. Corpus luteum produces estrogen and progesterone, and if there is a pregnancy, corpus luteum remains. If there is no pregnancy, corpus luteum converts into the corpus albicans. But sometimes we have some abnormality during this process. Imagine if something happened that ovulatory follicle cannot ovulate, cannot open or rupture the wall of ovary. What happened? Ovulatory follicle stay in the ovary. Or in some cases, imagine that what happened if corpus luteum cannot convert into corpus albicans. Corpus luteum always stay in the ovary and cannot convert into albicans. These types of abnormality during this function of ovary, we say functional cyst. We have another cyst, anatomical cyst, okay? But here in the aspect of physiology, when there is a problem in the function of ovary, we say this is a functional cyst.